This video is on how to determine angles between 0 degrees and 360 degrees that have the exact same sine value. Quick reminder that you can think of sine as the y-coordinate around a unit circle. Okay, and we're going to use a unit circle in order to sort of think about how to determine the angles between 0 and 360 degrees that have that same sine value. Okay, so let's start off with this example right here. So we're going to look at this point P right here, and right here, this point P is at an angle of 25 degrees. So from here to here, it is 25 degrees. Okay. So if you wanted to find the y-coordinate of this point right here, you just type in the calculator sine of 25, and you'd get a number around 0.42. So what other angle, what other point around here would you have a sine value equal to about that, or equal to that? Since sine is related to the y-coordinate, what we can do is we can find where else here on this circle has the same y-coordinate, where else here has the same height. So if I draw a nice little horizontal line to here, this point right here, this point right here, actually let me use a different color. This point right here has a sine value that is the exact same as this point over here. I'm going to call this point over here point, let's say T. So point T and point P have the exact same sine value, which is about equal to 0.42. Now the question here is, what is the angle of point T? So if I drew a line here from the middle to point T here, how much is the angle from here to here? All right, so in order to do this, there are a couple of different ways. One way we can think of this is, since we know from our x-coordinate, our x-axis to this line right here, it has 25 degrees. Well, we would also know that from here to here is also that exact same degrees. So from here to there, that is also 25. All right. And a quick reminder, this right here is 0 degrees right here. And then up here, this is 90 degrees. This vertical line up here, this would be 90 degrees. 180 is here on the left. Down here is 270. So basically every 90 degrees is like a right angle. And then if we went all the way to 360, it would be here again. So 0 degrees, 360 degrees is at the exact same place. So what is this purple distance? From our x-axis to this line. How much is that going to be? All right. Well, if we know that this is 180 degrees, and when I say this, just for the record, the 180 is going from here to here. That's 180. That's what I mean when I say this right here is 180. So if I know that blue right there is 180, and I know that from here to here is 25, I therefore know that this purple line, this purple angle from here to here, that's going to equal 180 minus the 25. Or 155. So our sine of 155 will equal our sine of 25. Let's do another example. All right, let's do this example right here. So this says 250 degrees. So we're talking about the fact that point P is down here. Here's your point P down here. And this 250 degrees is saying from here, from there to there is 90, 180, and when we get to this line right here, that is 250 degrees. Okay. So where else on here has the exact same sign as 250, sine of 250 degrees? Sine of 250 degrees, just for the record, is negative 0.94, or about equal to that. It's our height. This is going down, it's negative 0.94. So where else on this graph does it have the exact same height? Well, start at this point P here. We're going to create a horizontal line until we get to the circle. So right there. This right here, which I'm going to call point T, has the exact same sine value as our point P. So now we just need to figure out what is the angle for T. I'm going to draw this line right here. And we're trying to figure out from here to here till I get to my point T, what is that angle going to be? Okay, so once again, there are a few different ways we can do this. Let me once again remind us that over here you have 0 degrees or 360 degrees. Up here you have 90. To the left here you have 180. And at the bottom you have 270. Okay, so one way you can solve this is by looking at, I know this vertical line is 270. So I could figure out the distance from here to here. How many degrees is that? Well, my orange degree from here to here, that's 250. And in my blue degree from here, let's do this, from here to here, that's equal to the 270. So if I know when I get to this line right here, that's 250. And then when I get to this line right here, that's 270. Then this distance in between is just the two of them subtracted. So that distance right there is equal to 270 minus 250, or 20 degrees. All right, so I know the distance from this orange line to this blue one is 20 degrees, and that's going to be equal to this distance over here. That will also be 20 degrees. All right, so let's do the degree for t. So remember, the degree from t starts here, goes all the way over to the line that connects t. Okay, and we know once again that this vertical blue line is 270. We know that this green distance is 20. So therefore, in total, my t is 20 plus 270, or 290 degrees. That's for my purple. All right, so long story short, my point P, which was 250 degrees, has the exact same sine value as my 290 degrees.